Hey Joe, it's your teacher. So what I got is that you're asking about the action potential and how it works. You're describing what occurs inside the nerve when the action potential is started. You're confused on some of the vocabulary though and the overall process of the action potential. You had a few questions regarding the cortical areas and the difference between the somatosensory strip and the motor cortex, which I'll address later. You seem to be confident in your understanding of the action potential, which demonstrates you have been paying attention in class, yet your terminology is just a little twisted. I'm going to use some images along with usage of the vocabulary to describe the process of the action potential to you. So, an explanation of the action potential. So, when an impulse is sent from the soma to the axon, it's in the resting state. The fluid outside the axon contains a higher concentration of positive ions than the outside of the axon. Neurons do not stay in this resting state. Sodium channels open and positive sodium ions flood into the cell. Once the cell reaches a certain threshold, the neuron becomes depolarized, sending an electrical signal down to the axon. Note that the action potentials either happen or they don't. There is no such thing as a partial firing of a neuron. This is known as all or none law. So they fire down the axon to the terminal buttons, which cause neurotransmitters to be released from the neuron into the synaptic cleft. The transmitter will attach the neurotransmitter receptors on the photosynaptic side. Synapses can be thought of as converting an electrical signal into a chemical signal in the form of a neurotransmitter release, and upon binding of the transmitter to the postsynaptic receptor, which then travels from one axon to the dendrites of another neuron, and the process begins again. So a couple things I just want to show you. You have your neuron right here, and what's important to remember is that it goes from dendrites to soma to axon in that order, and soma is going to be your cell body where information is stored. Next thing we want to look at is a picture of the synaptic cleft. So you have your axon terminals, your synaptic cleft, and then your dendrites down here that are collecting. Okay, but it's important to note that the neurotransmitters go in and through, and you've got your synaptic vessel, and then your dendrites down here collect that information. And lastly, here's another cell-to-cell, neuron-to-neuron communication. And like I said before, it's just important to know that messages are received by dendrites, processed in the cell body, and then sent down the axon, where the action potential happens to go to the dendrites of the next cell. So a couple of things to know about the action potential would be that information is collected by dendrites and sent to the soma. In our initial conversation, you were under the impression that it was sent from neurons to the axon, and that's not true. It has to go through the dendrites. Another thing is that you want a positive charge on the inside of the cell. You second-guessed yourself and said negative. Remember, always trust your initial thought. Lastly, remember that it fires down the axon to the synapses, which leads to a terminal button to be processed and sent to other dendrites. So your next confusion was going to be on the cortical areas. The cortical areas fall under the cerebral cortex, which is divided into two halves, the left hemisphere and the right hemisphere. The cortical areas consist of 4 lobes with one mission. You have the occipital, parietal, temporal, and frontal. Your occipital is your vision, which is located at the back of the brain. Parietal is touch, located in front of the occipital lobes, but behind the frontal lobes. And then you have temporal, which is hearing, and it's located below the parietal lobes and in front of the occipital lobes. And then you have frontal, complex thought, which is located at the front of the brain. You seem to have some confusion on the terminology when we last spoke. Remember that the temporal lobes control hearing. When you have a headache, you rub your temples. For occipital, think your mom telling you she has eyes in the back of her head, and you remember that occipital is associated with vision, and it's located in the back of your head. Lastly, you asked me to explain the difference of the somatosensory strip and the motor cortex, and how the two work together. So placed between the partial lobes and the frontal cortex, or in the frontal lobes, are the two strips called somatosensory cortex and motor cortex. The lobes are the two strips. The somatosensory cortex coordinates the sensory data that comes from all over the body. It uses its close proximity to the parietal lobes and helps to navigate. Whereas the motor cortex coordinates our bodily function. It uses a strong relationship with the cerebellum. The coordination between the two is what keeps us functioning from day-to-day life. If one is ruined, then it will cause issues in everyday activity. I really hope this helped you. Let me know if you have any more questions.